This is lesson 25, all about factorials. I love factorials because it looks like the numbers are excited. It's not 8, it's 8. It's not 2 and 4, it's 2 and 4. Like they're all excited. So I love factorials. So when we're talking about counting problems, sometimes we will have to use this expression, what we call a factorial. So n factorial, if I have n as a number, we take the product of all of the positive integers from 1 to n. We can only take factorials of integers, so whole numbers, and we can only take factorials of positive numbers. So for example, 4 factorial is all of the numbers between 1 and 4 multiplied together. So 4 times 3 times 2 times 1. We take that product and it is equal to 24. 5 factorial is 5 times 4 times 3 times 2 times 1, and that is equal to 120. So the factorial is not defined for negative numbers, and we define 0 factorial to be 1. It's just kind of a rule that we have, otherwise math would break. So we just defined 0 factorial to be 1. So let's evaluate some of these expressions. So 8 factorial is equal to the product of all numbers between 1 and 8. So this is 1 times 2 times 3 times 4 times 5 times 6 times 7 times 8. Now the thing with factorials is they grow really fast. So if I were to multiply all these numbers together, I get, if you can believe it, 40,320, which is a pretty big number. Go ahead and try it for yourself if you don't believe me. So yeah, factorials grow super fast. So that is 8 factorial. If I wanted to do 2 factorial times 4 factorial, this would be, well, 2 factorial is 2 times 1. 4 factorial is 4 times 3 times 2 times 1. So this is equal to 2. 4 factorial is 24. So this is 48. My next 2 examples involve division, and I'm going to show you a trick so that you don't have to completely multiply everything out. Otherwise, it gets really big really fast. So here I have 7 factorial over 4 factorial. So let's write out what this means. So 7 factorial over 4 factorial. So on the top I have 7 times 6 times 5 times 4 times 3 times 2 times 1. On the bottom I have 4 times 3 times 2 times 1. So I'm multiplying here, and because I'm multiplying, if I have things in common on the top and the bottom, I can cancel them out. And here I do. I have a bunch of stuff in common. So I'm going to, again, since I'm multiplying, I can cancel this 4 with this 4, this 3 with this 3, this 2 with this 2, and this 1 with this 1. After that, I'm just left with 7 times 6 times 5, which is equal to 350. Additionally, if I have something like 7 factorial over 5 factorial, 3 factorial, I can do the same kind of thing where I write it out and see what cancels out. So 7 factorial over 5 factorial, 3 factorial equals 7 times 6 times 5 times 4 times 3 times 2 times 1. 5 factorial is 5 times 4 times 3 times 2 times 1. 3 factorial is 3 times 2 times 1. So I can cancel some stuff, but I can cancel it from multiple places. So here I'm going to cancel this 5 with this one. 4, 4, 3, 3, 2, 2, 1, 1. So here I am left with 7 times 6. And then I still have that 3 factorial on the bottom. 3 times 2 times 1. But if I multiply out 3 times 2 times 1, that is equal to 6. So then I can cancel this 6 with this 6, and I am left with 7. So when I'm dealing with division like this, it's super helpful to write it all out and see what cancels and then simplify from there. So we'll be using factorials quite a bit in our counting problems. So this was a brief introduction to them. And that is all for today. You have made it through 3 lessons. So I will see you on Friday. Have a wonderful day.